Good morning. Welcome to Rogni College of Engineering and Technology. Today we are going to see the concept aperture antenna concept. I am Reggie, Associate Professor, Department of ECE. Antenna aperture concept. Once you know the antenna aperture concept, students will be able to define aperture antenna and wire antenna. Aperture antenna. The term aperture refers to the opening in the otherwise closed surface. As applied to antenna, aperture antenna represent a class of antenna that are generally analyzed considering the antenna as the opening in the surface. Typically, antenna fall into the category slot, horn, reflector, and lens antenna. Aperture antenna are most commonly at microwave frequency. Aperture antennas are very practical for space application because they are flash mode on the surface of aircraft. Their opening can be converted to dielectric material to protect the environmental condition. This type of mounting do not disturb the aerodynamic profile of the craft, which is high speed application. Wire antenna versus aperture antenna. The radiation characteristics of wire antenna can be determined once the current distribution of the wire is known. For many configuration, however, the current distribution is known exactly and only the physical intuition or experimental measurement can provide a reasonable approximation to it. This is even more evident in aperture antenna. The central idea used in the analysis of aperture type antenna is the conversion of original antenna geometry into equivalent geometry which is booked at radiation through the aperture in a closed surface. In case of wire antenna, the field of an antenna are expressed in terms of vector potential, which in turn is the integral over the current distribution of the antenna surface. The major difficulty in computing the field of aperture type is the integration over the complex surface of the antenna. This issue is somewhat simplified by converting the antenna into the aperture problem using the field equivalence principle. The aperture geometry is conveniently chosen on a regular surface so that integration can be carried out without less effort, as all that needed the knowledge of the tangential E and H field in the aperture to compute far field of antenna. Obviously, some approximation is involved in determining the tangential field in the aperture, but in general, the computed far field are fairly accurate for all practical and the sufficient care is taken at the arriving of approximation. The field equivalence is a principle by which actual sources such as antenna and transmitter are replaced by equivalent sources. The fictitious sources are said to be equivalent with the region, but they produce same field with that region. FEG is based on Hygiene's principle and uniqueness theorem. Hygiene's principle states that each point on a primary wavefront can be considered to be a source of secondary spherical wave, and the secondary wavefront can be considered the envelope of secondary wave. The uniqueness theorem, a field in the lastly region is uniquely specified by the source with the region plus tangential component of electric field over the boundary, or tangential component of the magnetic field over the boundary, or farmer over the boundary. For a given set of sources and boundary condition in lossless medium, the solution for Maxwell's equation is unique. Consider the source free volume in isotropic homogeneous medium bounded by the surface. The field inside is produced by the source. Let Ez H is the possible in the volume V. It is shown that tangential E or tangential H in the same surface for two set of solutions, the field are identical everywhere in the volume. This is called uniqueness theorem. It is important to note that to know sufficient adequate either a tangential or tangential component solution to be unique. In other words, source free region the field are completely determined by the tangential. Although the uniqueness theorem is derived from dissipative media, one can prove that the theorem for lossless media by limiting sources tend to 0. Love field equivalent principle. Consider a set of current sources in a homogeneous isotropic medium producing the electromagnetic field E and H everywhere. Enclose the source by closed surface, separating the entire space into two parts, volume V1 containing the source and volume V2 being source free. Let the surface be chosen and it is also a source free. Let N be the unit normal to the source drawn. Field and sources. According to field equivalence, Jn is equal to N into H, M is equal to minus N into E, where E and Phi are the surface by the original source. Hence, the virtual source produced by the null field everywhere in E. Hence, Ms represents the magnetic field density, Js represents the kinetic field density. Three forms of field equivalence: surface current density, Js and Ms on the surface current density, Ms on the surface is conducting plane, surface current is Js on the surface with the magnetic conducting surface. The proof of the principle make the uniqueness theorem. So specifically consider a situation where the volume in V2 are same before, but we delete the sources, hence the field to be identically 0 everywhere. Since the tangential component E and H satisfy the boundary condition in the solution Maxwell's equation and the uniqueness theorem, it is the only solution. Let us assume the field S is replaced with a perfect conductor. Introduction of perfect electric conductor shorts and electric conductors exist in the magnetic field. Let us assume instead of placing a perfect electrical conductor within S, we introduce a perfect magnetic conductor with a short with magnetic current density and reduce the equivalent problem. Horn antenna. So some of the application microwave antenna used as feed element, used as feeder for reflector. Its widespread simplicity in ease in construction, large gain prefer over the so already we discussed about horn antenna. Horn antenna can be fed or open out waveguide. Thank you. So these horn antenna design principle, horn antenna designs. So all are previously we explained with another one. Thank you.